Hello. Is it audible now? I think it's good. Okay. So let's go for working. So today with the simple linear regression, I'm going to explain you the life cycle first. Okay. I'm not giving you a full knowledge on that particular simple linear regression, means regression problem solving. But first, I'm going to explain you the whole structure, because that whole structure we can use on the multiple algorithms, is whole machine learning working, okay, on the whole machine learning algorithms. So now, so let's go for this one. I think I'm good. It's visible. Okay, great. Wait, I'm sharing my screen here. Question. Which all environment do we need to use these algorithms? I think everyone has an Jupyter notebook. These are the tools as well as Anaconda. And if suppose if you want to use, there we have the SQL library. Because if suppose so many libraries, machine learning algorithms are present into where in sklearn, right? Scikit-learn library. So just check out that your sklearn library is present or not. I think we have, definitely will get that one. So many people they are having the problem into the updation. So make sure that your Jupyter notebook, means your Anaconda, should be get properly updated. Okay. So let's go for the work here and just giving you work. ML life cycle. Okay. So let's go for the work. See, I'm going to implement one structure in front of you. Okay. Once I implement, no, I'm going to tell you the how the stages are working. Okay. So the way I'm going to work, definitely you will get some big amount of questionnaires, but it's okay. So whatever the questions you are going to ask, I'm going to tell you. But I'm telling you the steps first. Okay. I will represent the steps, then just check out how the each step is used, how the each step is used means we can complete each stage of getting a prediction point. I mean, till the prediction point, how we reach that whole structure I'm telling you. And it's not like that the only one algorithm has in this type of stages. The whole structure, the whole machine learning algorithm is having this step-by-step representation. Because machine learning has a structural point, that's why I'm just telling you the whole structure. The first point we are going to work on that is an importing the libraries, right? Step one. So I'm just passing here step one. See, I'm telling you machine learning life cycle. Okay. And yesterday also you have, I think, even we have discussed about the structural point and so many. Yesterday, I think some of the questions I really appreciate that those guys asked on the basis of like how much accuracy we can expect from the machine, how much data we should need to implement. Is it correct? This kind of questions you asked me. Yes or no? This is enough. First step. Step two. Am I audible to you? Step two. What is the step two? See, the step two is in getting a ready, means getting the data loaded. Okay, so just go for the data load data set is equals to pd dot read csv. So I'm going to ask you some questions with this one. Okay, so the first data set, I will take a simple linear regression. That's why I'm just going for the data set. Wait, I will take one data set here. Hmm. What is the name? Salary. No, 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 this is not a repeated class, sir. This is a new class. This is fresh. Means about yesterday you are talking. Some of the facts that we are going to use, that I'm discuss here, not an issue because sometimes when we are going to discuss, in any session, some points will be increased. So don't worry about it. I will tell you. What about yesterday's we missed? Some points that you have missed, but don't worry. I will tell you today only. Today also. I mean, Saturday is supposed to be a fresh class, and Friday must be a repeated. Yeah, most of the what will happen when we go for the discussion. Some of the questions will ask me by the students. Like even yesterday, I never expected to get some answer like how much accuracy we get, how much data set we needed. This kind of questions will rise some important issues. So that time I explained them. Okay, but don't worry. Yes, Rohan, that is. Friday we don't do. We only attend the last class on the. It's okay, no problem, sir. I will tell you. May I know? May I know if this salary data says we will say? Yes, yes, salary data. This is simple linear regression data set that you are going to predict a salary on the basis of year of experience. Don't worry about it. I am going to explain you all these things, and still some of the people are joining. That's why I'm just starting this basic work here. Step one, step two, right? And then we are going to work on the another part about prediction. So step one, salary data you can get it through the Kaggle as well. Else I will upload that data set on portal. So don't worry about it. Okay. Actually, I have to check for that. This is common data selection. See this one. You got this one? Yeah, this is first step that you're going to enter into the data set in the machine learning. Okay. So don't worry, I'll teach you everything. If suppose some of the extra point you want, then that also will go for that. Okay. See, the first stage when you are going to implement any machine learning. So many guys from the software background and they know that about software development life cycle, right? Am I correct? IT, those are in the IT background, no? They know the SDLC, agile technology, or if suppose waterfall model kind of structure. So why to discuss about this? If suppose any project, any client project is coming, no, that time you will go for the some stage by stage execution of that product. Means what will happen? See, sometimes what happen? Suppose if I'm getting any project, that time the requirement analysis first stage, then designing, then coding, then testing, then user acceptance means your expected product features are meeting or not. The last point that we are doing, that is nothing but software life cycle, means software development life cycle, that we have waterfall model or agile technology kind of things. But similar kind of structure we have into the machine learning as well. So if you want to define, if you want to implement any machine learning algorithm, that time definitely you can go for the some structural point, means top to bottom. It's kind of structural one. So you are going to enter into the stage by step implementation of your algorithm. So before you learn about any algorithm, we have to know about stages. See what I'm saying? Before you go for the machine learning any algorithm, you just go for the stage by stage representation. So that's the major thing. So let's go for that. We can. I'm just waiting for to explain all these things, right? So let's go for this. The first stage you have to import a library. Second stage you have to import your data set into the implementation of machine learning algorithm. And the third stage, step three. Okay. Step three that you have to mention here, data slicing. Data slicing. So what is the data slice? See here we have only two columns and I want to predict a salary. See what I'm saying? I want to predict a salary on the basis of a year of experience. So can you tell me who is the dependent variable and who is the independent variable? Can you tell me, please? who is a dependent variable and who is the independent variable. Salary is a dependent variable. That's correct. Salary is a dependent because you are going to predict no salary. You are going to predict salary. That's the question. This is why I'm just taking this session. I'm not directly entering into the algorithm. Why? Because you guys have to know about how to choose your features, how to choose your dependent variable. See, if I'm saying like, if I say I have this much year of experience and I want to know about my salary. Suppose Infosys company is there or any suppose Facebook company is there and they what they want actually they they have already last 10 years of data of their employees and they have the data kind of on the basis of experience means employees data on the basis of experience they have already some structural point. But what they want now, if suppose your company's CEO is changed, right? And what's the structural part, even new CEO also doesn't know about how to salary processing works and all, and how suppose new new employees coming into the company, then how to proceed with the salary, right? That time that new CEO is deciding to go for the simple linear regression to know about salary, how to give means how much salary we have to give to the particular new employee. That's the question. I think you got my problem statement now, right? So now what's the matter here? If suppose if I'm thinking about year of experience, there we have 1.1, 1.3, 1.5, right? And that there we have the salary as well, means current employee salary. And I know you guys are thinking about sir, data is in here we have 30 only, and you are going to predict a salary. Or see, always think about it. How much data you are teaching, that much level of accuracy you will get into the prediction. So for the teaching purpose, I'm taking this much small little salary means small point. But don't worry about it. I will go for the detailed explanation. Salary is also dependent vary on the position. Are we assuming here that the job is same for all the employees? Yeah, that's the thing. We are expecting the job positions having in the same. So we are not like it's multi-positional. No. Here we have expecting one position. Got the point maybe, right? So now for the teaching purpose, because your machine learning, the word is there. No? So we have to train our model. What I'm saying, we have to train our model. So if I'm going to train our model, then model we have to tell our model this is an independent variable, this is a dependent variable, right? I'm telling you, correct? No, we have to we have to tell our model that your independent variable is an year of experience and your salary is an dependent variable is in prediction value. And if you are passing this value into model, how can you pass? Then you have to tell, you have to give some variables like x-axis, y-axis, you pass down the independent variable into the x and independent variable into y. So how do we slice that data and pass it into the particular x variable and y variable that we are going to implement here now? This is my step 3. So every structure, see, I'm not telling you about this simple linear regression algorithm or every algorithm has this kind of structure, this kind of structure. So let's go and first make out a differentiation between x-axis, who is an x-axis features, and who is a y-axis dependent variable, right? So let's go for this one. So x is equals to data set. We are slicing data set, no? So data set, your data set should be there. Okay. Data set dot ilog. Who is an ilog? Ilog is nothing but independent index based slicing. What I'm saying? index based slicing, right? And now you are passing here colon, comma, colon. What is the first word about colon? What is the first word about colon that is in all the rows? Yes, exactly. All the rows. All the rows. Okay. And what I'm going to do here, the colon minus 1. See, colon minus 1. So now if I'm expecting my this which one? This year of experience into x, means I'm going to transfer that year of experience into the x, then definitely this structure is useful to you. The second value that is in after comma, second value is in colon minus 1. So by default is in 0, and minus 1 is nothing but range, this one. So if suppose if you are not passing any value, there is in 0, and minus 1 is who is that? Salary, right? If suppose if I pass this range kind of this one, then definitely your x value will get a year of experience. You got the point? How do we get that year of experience? Because there is a range, no. So range n minus 1 concept will applicable, and you will get a year of experience here. Now, similar kind of structure that we are going to pass into y and the data set dot ilog colon comma. Now I'm passing minus 1. So who is my minus 1 here? Who is minus 1? Salary. Exactly. So we should have to check about whatever the data we slice down into the x and y, no, that's the matter. So now the question rises here. Here we have the only one structure, means only one independent variable and one dependent variable. Obviously, many of the question will rise here. What about multiple linear regression? Or if suppose we have, what about multiple columns will be there, and what can you do? Say, the major discussion about independent variables and dependent variables, that is the major discussion. Whatever it may be, if suppose if I'm thinking about whatever it may be the features you are passing, but dependent variable should be one, no, you are going to predict only one. If suppose salary is based on the 4 to 5 features, then definitely what's the matter there? You should have to manage a 4 to 5 columns should be there, right? I think you got the point. I will tell you now. A question, I think, is it x is independent variable? Yes, it is, sir. It is independent variable. Please explain x again. Why you took this range? See, you can take with the range like 1. Who is the first position? 0, no, there, right? The colon, the first you passed here. I want to fetch this x, so I can fetch with the anything, means I'm just passing that I want to fetch that first row. That's why I'm just passing colon minus 1. You can get it easily. Whatever it may be that I want to slice that data column into particular variable. So why you took this range? See, so everyone has a different structural point, means everyone has a different point of view to fetch a value. So if suppose you are independent variable into the first position, you can pass that 1 and fetch it. There is that value is in 0th position. That's why I'm just passing that colon, because by default, who is the first value by default? 0. Who is the minus 1? Who is in last position? So that's the range we got, that n minus 1 you will get, and that x value, that's it. Got the ma'am? Great. So now let's go for some discussional point. Means now the question will rise. I will upload one more data set here so that it will give you some important topics. Okay, I'll take this one once again. See, it's not a new step 4 or something. Just I'm giving you some discussion topics. That's why I'm just taking here because some of the problem statement will be removed. Uh, Another data set will take. Mhm. Okay, I will take a hard disease. See, here we have the multiple columns, and that previous one, that simple linear regression purpose, I have taken that is 2 columns only. The question now I'm getting here. So when we have more than independent variables, we slice them into one value like a x or new every value a variable. The question is very nice actually. That good question. See, it's not necessary to take every column here means new variable for the each column. It's not necessary. You can slice down. I will tell you now. That's the thing I'm just telling you, and you will get solved this one. Not an issue. I will tell you now. Just one. So what is the new question? So dependent into one variable, rest in one. I guess. Yeah. Remaining also means independent variables are there is not a necessary that only one column will come into independent variable. See, if you go for the multiple linear regression or logistic regression means multi-classification problem statement, you will get near about 7 to 8 features into the x-axis. That time definitely you will take this one. So check out, I'm working on this one as well. So what will I do? I'm taking x1. See what I'm taking here? X1 is equals to data set dot ilog and colon. See what I'm doing? Colon comma and what I'm going to do here, I'll pass here age to this one till now, this one. So, so hard problem. So hard is nothing but there we have the multiple age peoples and we have to predict that who is there that we can get hard disease, hard problem. Okay, so we have to show them that you guys has a hard problem and you don't have. So there we have the females and males data set as well. So I'll tell you how impactful these data as well, right? So you will get some little bit funniest thing that this kind of structure also will there. Okay, so you will get this one. So just go for this one. X1 is equals to dataset dot ilog and I'll pass here range. So if suppose if I want to pass the age to this, I think maybe thyroid or something column is there. I don't know the big name, but tell me what is the range here we have to pass. Is there any range? This is my zeroth position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So can you tell me the range? What? 13? Because I want to slice down the X features. I think the one question that I got from the when we have more than one independent variables, we slice them into the one like that. You will get this kind of answer here. So check out. Oh, sorry, I have to do like this one. See, dataset one, age two, this one, THALL column, this which. See, this is your whole data set. Okay, this is your whole data set. And now when I slice down that colon comma colon 13, this is your x1. Now you got solved about one question problem, that is you can have multiple columns into the single variable. Okay, can we go forward now? I want to add a output column into where y1. Similar kind of structure I'm going to use here. So I'll pass here y1 is equals to data set 1 dot ilog, and I will pass here colon c colon is nothing but rows. Okay, and -1. So -1 is nothing but your y data. So y is nothing but dependent variable. So once I execute this one, you will get to know that yes, it is that y1 is there. See, this one is an y1, and that x is getting that x1 is getting the till the h2. This one I don't know the pronunciation. PHA double L. Okay. So question is now pandas are important stuff for the machine learning. So we need to, yes, Arnab, you should have to learn so many things actually. Once you learn the pandas, no, you will be able to go for the analytical problem solving. Means you can solve the big problem statements throughout um, in not only machine learning and data analytics also for the data analytics studies. Why we are doing the slicing? See, your machine learning can understand machine learning when go for the prediction. He has to know that which part you want to predict, which part I have to learn. Means if suppose I'm a machine, then machine has to know no which part I'm going to predict, and which part on the which features I have to go for the prediction. So features I have to know, prediction point I have to know, then I will go for slicing. I would like to know for the x value means your features and y value is independent variable. Are you getting my point, sir? Yes, great. ML is only understand. Definitely, you will go for the new things. Don't worry. See, you got that slicing. It's not necessary go for this is not a big thing, but see, whenever you go for any project or any programming or any algorithm, that times just listen, just do one thing that you have to train your model. Without training, he can't do anything, right? Why? Because if you are thinking about, I'll go for the one question. I will ask you one question. Is it possible that you are going to, if you want to predict something, is it possible that you can pass a multiple dependent variable in a single algorithm? Multiple dependent variable in a single algorithm. Is it possible? I'm asking you a question, guys. One says no. Okay. We should be. There might be some ways. No. What kind of ways, Rahul? Not in, see, you can do the separate projects and separate data set structure, but you will teach no. If suppose there is an unethical ways, then that is also I don't have. Why to go for the wrong teaching with you guys? So now, see, there we don't have any kind of dependent variable. Means a single prediction point, you have to need a single dependent variable. So don't worry about it. Okay, this is my step 3. Step 4, see what I'm telling you. Step 4 is nothing but you have to divide your whole data set into a training set and testing set. If you take two columns in a X, will that not work, you mean? No, no, you can take a multiple columns into X. But if you think about a simple linear regression, then there should be a one independent variable and one dependent variable. So why should I go for the multiple variables? If suppose if I'm taking a multiple columns into a X variable, then definitely that is nothing but your multiple linear regression. Are you getting my point? What is the difference between simple linear regression and multiple linear regression? Uh, you have to divide your data set into a training set and testing set. Now I'm going to tell you what is a training set and testing set. So first I will implement that code and then I will go for the explanation. I know you will ask for many questions now. Why? Because this is the major part that your machine is going to learn your data set. Okay, so let's go for this one. First, I'll go for uh, importing libraries. So let's go import, sorry, import sklearn dot, see what I have passed, sklearn dot model underscore selection from sklearn dot model selection, import train test split. This is my class. See what I'm saying. From sklearn dot model selection, import train test split. So predefined library is there. So sklearn is my library, scientific data analysis purpose. Okay. Dot model selection is my sub library. You can say package. So using model selection, you can slice down your, you can click, you can select your model, and train test split is your class. Train test split is your class. You can say class or you can say library. But train test split will be useful to slice down your data, your whole data into testing set as well as the training set. Can you write down those things first? Yes, yes, I can. Do you know SQL? Scientific data analysis? I'll tell you, don't worry. I'll tell you. Mathematical analysis. We can say scikit-learn as well. Okay, scikit-learn as well. SQL is nothing but scikit-learn as well. Now, second, Okay. Train test split also useful for the testing. Actually, these are the packages: model selection and training testing splitting useful for training set, creating a training set and testing set. So it's okay. Now we'll go for the next one. So now I'm going to implement here that is xtest, xtrain. I'm going to tell you now, but I'll first implement this code xtrain, xtest. Now check out. I'm taking a 4 variables. Don't worry about it. I will tell you each and every point. Okay. Split into the bracket. Okay. So let's go for explanation. Now that there we have the 4 variables. See, once we import scalar model selection training testing set, there we have how much? 4 variables. So the 4 variables that we are dividing into the training set and testing set. So you guys are thinking about why to slice down the training set and testing set. See, if suppose the way previously also I told you about, suppose there we have the 100 doggies, okay, and you are going to teach your model means or any child or something, or you can think about model now because we are working in the machine learning. So think about machine or model, okay, and you want to detect your dogs only means out of all the animals you want to detect only 100 dogs only, right? And your what do you think? Your model should give the proper explanation, means proper detection on the basis of that. So what you are going to think about? Why not I teach? Why not I train our model to detect only doggies out of all the animals, right? So that time what I am going to do? I will take the 100 doggies, and out of 100 doggies, 80 doggies I will teach to the model. This is nothing but your doggy. This is nothing but your dog. Okay. So with the features I'm teaching to my model. So your model is accurate or not, to understand purpose, to finding purpose, what I'm going to do? Out of 100, I divided my data 80 and 20. I divided my data 80 and 20. 80% I transferred and trained to the model for the training purpose, and 20% I remain and I will take into the reserve purpose for the testing. If suppose whenever my model is learned that 80% of dogs data, then for the checking the accuracy, for checking my prediction is good or not, that purpose I will take that 20% of data and ask to the model, this is doggy or not. See, now the question rises here, what will happen? Why to slice? Why to give the 80-20s? Why not 70-30? Why not 50-50? See, that is in some common questionnaires. If you wait, I will take you one example. Now check out one example I'm just doing. I have divided into the 4 variables. I have divided 4 variables, all the data into 4 variables. Okay. Now what will happen? There we have x train and x. X train and X test. Can you tell me which data is going to divide into X test and X train? Which data? There we have an X column, no? Which column there we have passed into the X? Year of experience. Is it correct? You have passed a year of experience into the X. Right? And that X you are dividing into the two sets, that is a training set and testing set. Your, yes, independent variable. X is your independent variable. So you are dividing into the training set and testing set. So that's why I am taking here X train and X test. And second one, your second dependent variable, that is an Y. So what is the Y's value? Who is that Y? Salary, right? And that salary you are dividing into the X, Y train and Y test. See now, see now, this is your X data, means independent variable, and this is your Y data, dependent variable. Okay, now let's go for some explanation point. I know now I'm just creating one design here so that it will be easy to do annotation. See, I think in your right side you are getting this one. So check out. See, this is your data set. Okay. Actually, with this one, no, it's very tough to manage. And this is not a fixed. I want to draw in between this one. Okay. This is X and this is Y. It looks a little bit funny, but don't worry. And this is your X data and this is Y data, means Y is nothing but salary, X is nothing but independent variable. Independent variable is nothing but your year of experience. And now what we have seen here, we are having four variables and your whole data is going to divide into the four variables. So how they have divided your whole data set into four variables? So that they have taken whole data set, that is an X and Y. So you know that X is having that particular column, Y is having that dependent column. Then what I have passed, test size 0.2. So whenever I pass test size equals to 0.2%, then definitely your whole data set is divided into the 80% and 20%. Means your testing data is at 20% and remaining 80% is into training set. So now you guys are thinking about 0.2% is nothing but 20%. Yes, 0.2% is not 20%. Let's check out one thing here. So the way I have passed the test size is equals to 0.2%, then your whole data set is nothing but your 100%. 100%. And the way I am passing, the way I am passing this is 0.2%, that is nothing but that is in 20%, then your whole, oh, what, your 20% is this one, 80% data is this one, means X, this is train and this is X test, Y train, Y test. Are you getting, guys? Are you getting this one? Means just think about simple linear regression, because there we have the one independent variable and one dependent variable, right? Yes, Nishant, I'm just repeating once again. Still, uh, still, still we haven't gone through the random state. Do not think about random state. I'm telling you now test size only. Okay. Why we have taken the four variables? Why we have taken the four variables? Because once we divide the testing set and training set, we have to check who is an X test, who is an X train, who is a Y test, who is a Y train. The way we have passed X data and Y data, here we have assigned test size equals to 0.2%. 0.2. So the way we say the 0.2, definitely your whole data set is dividing into the 80% and 20%, because you are deciding that testing part should be a 20%, means 0.2%. And once you pass the testing size equals to 0.2%, then remaining part is in how much? 80. That's correct. So we can increase the test size. Yes, you can. This means if suppose if I say here 0.3%, then that is become 30%, and remaining is in 70%. If you pass 0.1, Rohan, why we take test? I will tell you. I will tell you. Don't worry. I will tell you. Go for that. Okay. If you pass 0.1%, then also that is a 90%. Now, now you guys are thinking about. See, you guys are thinking about what is going on here. Means now we have sliced down the training set, testing set, and we got an proper, means we got our 80% data, 20% data. You know what will happen? What is the application of this ratio? Yes, I'm telling you now, Vishan. Just see. Now just see here what I'm just asking to you all question. One question I'm asking to you all. Tell me, who is an extreme? This is, yes, this is extreme. Say me yes or no. This is extreme. Yeah. So this, once you hit this training testing split this data, your extreme will goes into where? Extreme. Now you guys are thinking about how that data is going. Actually, you are using this library. This class is you are using. That's why they are telling you. Are you getting a point? You got the point. Your X-train data goes into the X-train. Your Y-train data, goes into the Y-train. Your X-test data goes into the X-test, and Y-test data goes into the Y-test. I know I have done some scrambled things here to understand purpose, but tell me if you are getting the proper things, then else I will do some different example with you. But if you want this one, then it's okay. Question. 20% data is taken to the check the standard deviation if the salary changes. Standard deviation is not like that. Actually, whenever your model is giving you output, because your 20% data is in your actual data, no? Yes, sir. Is it correct? Your 20% data is in your actual data. Means you know that answer already. If you want to check accuracy of your model, you have to ask your own question to the model first, and then you can ask other questions. Are you getting my point all? Are you getting my this Example, I will give you one example to you to why to take this test and train this kind of structure. The percentage depends on the data set, not like that. Actually, what will happen? Wait, I will tell you one thing. I will give you one example to you. Yes, Rohan, I'm just telling you now. Yes. One example I'm telling you, and this will helpful to you. I think previously I told you, I don't know, but this one. See, HDFC Bank data. See what I'm saying? HDFC Bank data, credit card fraud detection data, and HDFC said that suppose to me, HDFC saying that Abhay, this take this credit card fraud detection data set and tell me who is in fraud or not. Okay. And HDFC gives me a 3 lakhs of transactional data set. And what I have done, I have taken that data set and trained to the model, right? If I want to test that accuracy of my model, what I have to do, I have to divide my data. I have to take some of the observational transactional point to the side. Why? Because already I have some transactional values, that already decided values means that transaction is true or not. Already I have some questions and answers. I know some answers like that. So once my model is learned, then what I will do, that remaining problem statement I'm going to ask to the model. Tell me this is correct or not. Why? Because already I know that answer. This, if suppose I have one transaction fraud, I have to ask to the model, and model gives me that transaction is true. If suppose model is telling me that transaction is true, then what will happen? Already you know your bank said that transaction isn't wrong, but model is telling you that transaction isn't true. Means tell me now, who is correct in this format? Who is correct? Your actual data is correct or prediction value is correct? Exactly. Because are you getting one point to you? You are not teaching only independent variables. You are teaching dependent as well as independent variables to the model. You are not teaching only independent variables. You are telling, see, this is my 2 years of experience. I'm giving $4,000. This is 3 years of experience. I'm giving $6,000. This is my 1.1 years of experience. I'm giving $1.9. So this is already you are telling, means your independent variable and dependent variable already you are teaching. Only some of the independent variables and dependent variables, some of the data you are taking side. Why? To check your model is performing well or not. That's why I'm dividing this data into the training set and testing set to know about my model accuracy. You got the point now? Yes. Yeah. Now the point to be discussed here. Now the point to be discussed. Model accuracy, that's what I tried to say. Okay. Actually, what will happen? Some of the suppose multiple questions I'm getting that time. Some of the questions I'm getting through the private. Some of the questions I'm getting in public. So little bit it's not model accuracy. That's why I done. Model accuracy. See, I will tell you that one also, because some of the so many points to be discussed here. You will get headache now. In the 20% of data, how can we be sure that the actual models works? Huh. Good question, sir. Actually, your 20% data is an actual data, means your own data, right? And if suppose your model is giving proper answer towards the means similar kind of answer about testing, means you have divided your testing data, no? And once your model is learned, and what you are going to do, you know, what you are going to do, you will take that data set, testing data set, and you're going to ask to the model, means you are going to ask to the model about this is correct or not. But you are believing on your actual data, you are not believing on your model. Why you are saying, why I'm saying like that? You are believing, that actual data is correct. Actual data is correct means you can slice down the data into 10%, 20%, or 30%. It's not necessary, because your actual data is in trustful, but your model is not trustful, because your model is, it's kind of means model has a different ways to learn, means the machine learning algorithm has, because machine learning has a near about 7 to 8 algorithms, right? And machine learning has an ways to teach to the model, means sometimes if suppose regression has a simple linear regression, multiple linear regression, if you go with the suppose logistic regression, KNN logistic are different ways to teach our model. And that time suppose even you have divided your data into the 80s and 20, logistic will give the different answer, KNN will give the different answer. And now definitely you will ask to me, who is the best algorithm? See, you cannot believe on the machine learning. First up, what I'm saying, you can't believe on the machine learning output. You can do the assumptions. Tomorrow will be the rain. That's it. You cannot say like 100% sure shot there will be the rain. What the point? Because all the things are natural. How do we trust the output of the model? Just take a risk. Yes, sir. That's why I'm just telling you. Only risk. Risk factor means assumptions. Means you can say tomorrow will be the rain, or suppose you will say that suppose if you predicted the salary, if you predicted the salary, what do you do? 2 years of experience, there should be a $6,000. Maybe if suppose you are thinking only your model is giving 6,000, but your actual data is saying that only $4,000 you have to say. But you will say there is a difference between actual is and 4,000 and your prediction value is giving you $6,000. Then the $2,000 difference, that is a huge, and that is an error. That is a huge, and that is a huge big error. Then that time definitely you have to work on your model. Why? Because there your prediction value should be comes near to the actual data. If suppose your actual data is saying 2 years of experience, $4,000 salary, your prediction value lies between the somewhere into the 4,500 or something like a 5,000 or something like a 3,900. Are you getting my point? You got the point? What I'm teaching, telling you. The question actually I never saw that one. Like we take blood samples to know about our blood samples, but there is not in our favor, can be a big loss to the company, thereby that hampering the data in this position. Not like that actually. Got a good point here. Okay, we can't predict the market will goes up by previous data set share market, because today is an World War thing. Yeah, that's the point. If suppose even you don't know that, if that is an external factors that affecting on your markets. Are you getting my point? That's the external factors. No, you can't say that. If suppose market goes well and you are saying that you tomorrow will be the stock price in this one, then definitely that will be the lies between that one. But the natural disasters and market stock price, war, gold is everything that depends upon the extra things. So don't go about that one. Or you can say if you go for the any company and you will say that tomorrow in the after 6 months World War III will be there and this much will be happening. This stock price will be there. This is the wrong thing. Okay, do not enter your third factors into this. Okay, so this position is for the make people predict what could be possibilities. See, uh, possible ways. I'm not saying that machine learning is a bad, but at least machine learning gives you some assumptions. At least machine learning gives you to believe something will be there. Are you getting my point? Something will be there. They are providing us some assumptions. Means they will say that there is an some kind of thought process will be entering into that direction. If suppose something will be happen into the future and you are predicting now and you are making try to make some study on it, then why not? Right? It means ML works by God, luck, time, and not like that. Your ML is works on the data, past data, and whatever happens into the past data, it's not necessary that will happen into future as well. So how can you say that machine learning is the best always? Are you getting my point? What I'm saying? Go on. Okay, I think we have spent on this topic lot of things. I think any questions if you have, guys, you can ask me question, not an issue. Okay, now the point is that the last point you never asked me, what is the random state is equal to zero. Now the point to be discussing point. Okay, and yes, random state is equal to zero. So I just want to, okay, I will not clear the here. Wait, I will do one thing here. Okay, see what I'm going to do. If I say random state is equals to zero, you know that there we have sliced your X train, Y train, X trace means we are going to slice down the data. Random state gives you while slicing the data, you are picking your data points randomly. You are passing into the X train, X trace means X data you are passing randomly because random state is equals to 1, or if you are taking 5, 10, 20, 30, the randomly 30 after that you will take that randomly picking up values and passing into the particular variables. And there we have not only the X data, there we have Y data also, means dependent variables also passing. So I will tell you how it looks like. Are you getting my point? How I'm just telling you about random state. So ML will get a string as well, or we slice only the integer floor, these two data set. No, machine learning only needs numeric data. We cannot go for string data set. You have to convert your data set. That's why we have learned about labeling coding. Okay. Wait, I will show you. See, our major target is in dividing the data into the X test and Y test. Is it correct? The major target is in dividing the data into the X test and Y test. That's the correct thing. So whatever the data will goes into the X train. No, now this X train data, Y train data is there. If I'm passing a random state is equals to 1, then randomly pick up means one after another, your data will goes into where X train. This is from the whole data set, means this is from the X test, whole X test. Not I'm saying a single one, whole X test, X data. Wait. This is little bit. This is a X. Just imagine this is, I'm just making a horizontal structure to understand purpose. Okay, this is my X data, X column. Okay, and you would like to go for a slicing of data into X train and X test. That's the matter. Okay, that's the matter of thing. What will happen here, sir? What will happen? This is not necessary to go for the random state is equals to 0, random state is 0. You can pass the random state is equals to 300 as well. Sir, are you getting my point? You are going to picking up the data from the particular that X data into the X train and X test. So you are picking up a randomly. So if suppose if I'm passing 5 to 10, 20, if you are passing X is equals random state is equals to 5, then you are getting your data randomly picking up after 5 after 5 into the X train after 5 means if suppose if you are saying that this is an 80% data you are passing into that. But what I have done here, wait. If suppose your X train wants 80% data and your Y train X, what happened here? Suddenly all this data is. This is 80%, this is 20%, this is 80%, and this is a 20%. Right? 80-20, 80-20. That's already we have done. So you are picking up a data from the X data randomly into the X train. So till the 80 will goes in 80% data. This is suppose this is a 100 count into the X. So how much the 20% that is an 80-20, no? If suppose data points are 100, then data will goes into the 80-20. So your X will pass 80% data, means 80 data points into the X train, but randomly. If suppose if I say here random string is equals to 1, he will pass through the one after one after another. If suppose if you are passing 2, then randomly. So you guys are thinking about why this is, why do shuffle? Yes, sir. Yes, Rahul. Data will not be shuffled. It's kind of shuffling. You are picking up a data. It's kind of shuffling. You are picking up a random data set. You are shuffling the cards like that, the similar kind of. But here, it's you cannot say no. Like you cannot say we are not doing into by hand. Your machine is doing. That's why you have to tell your machine that you can shuffle by two, means random state is equals to 2 or 5. It depends upon you. See, the impact of random state definitely happen into output. What I'm saying, impact of random state definitely that will impactful on the output. How? If you are saying random state is equals to suppose 10, your data is 101% data will changes into the extrain, no? Is it correct? Yes or no? Yeah, without repeating, not a single value will repeat on that extrain or X test because your only 100 data points are there, no? You got the point now. Why to make a duplication of data on the, if you are having a 100 data points, there is a not a repeating data, not in data redundancy will goes on here. Don't worry. I mean a 5 after 5 will position of data will be same. Position of data will not be a same. How can you think about data position will be same? Because if you are picking up a fifth number, then definitely it goes into the extrain into first position. Rahul is correct. Second, fifth number, if you are picking up, then that goes into the second position of extreme. Then output isn't completely different. Don't worry, I will tell you now. Okay, completely different. I'm not telling you today algorithm because these are the points that happens. That why I'm just telling you. Okay. Now just go for the one more thing here, so you can get it easy. Will not affect. So tell me, if it takes a fifth, then what about third, fourth? It goes into the looping structure till the data will slice down. Whole data set will slice down. How many times the whole data set will not go till that much time and will do the full data. It means full data. Yes, it is full data set. You are trying. Yes. Question. Random one means data will go up to one after another, two after another. Yes, randomly it is speaking. Yes, sir, that's correct. So you the question, not a single question I got from your side, that if suppose there we go for a if suppose that we go for the classification algorithm, your prediction value is based on the binary classification or multi-classification. What will happen? See what I'm saying to you. Just understand the one point here. Understand the one point here. If suppose if you have your dependent value is in binary 0, 1, 0, 1, 0, 1 kind of things, what will happen if you pass random state and test size? Your model will get a maximum numbers of ones, means your binary classification. No, there should be a possibilities of maximum numbers of ones into the extreme, and lower size of zeros will enter into X test. Data may get biased towards the particular category. The way I said about a credit card fraud detection, the biasing concept, how the model gets biased towards the particular thing. Yes, majority. If suppose he learns maximum numbers of majoritical concept, then definitely he goes into that direction. The way I said that binary, if suppose if you think about credit card fraud detection, HDFC Banks gives us a credit card data set, and you know that there we have the near about 2,85,4,000 true transactions, and only 4,500 of false transaction. If you train that data set to the model always gives to the favor of answer into majority. That's called we that biased model biasing. And their point comes imbalancing, data imbalancing. Their point comes data imbalancing. I think how much this line is impactful on your data, on your prediction. You got the point? So data imbalanced data, the data is okay to use predict. See, imbalancing gives you the point about model is learning too much about some sort of categories. Even after, if you make a balance, even after balancing also model goes into the biasing concept. Yes, Rahul, kind of going one way. Yes, can we put a random state? Yes, you can. See, it's not necessary that you can put 3, 4, 5. You can put anything. See, you are saying that my data set is in thousand rows. Means data points are 1,000. I want to put in through 2,000. That's the wrong thing. I'm saying. If you are at 1,000 data points are there, you can put there is an 50, 20. It's because you can believe on your data set that he can do the proper slicing. Means randomly. You will learn this kind of structure into the classification as well because regression gives you the continuous things. No, I think you got the point. So that's why your data, your X data or Y data would be means if there is an Y data, what is going on? Your Y data is divided into X train, X test, Y test. That's it. And whole 80, 20. This Y is data, these are Y data, and this is your X data. Which number we have to take? It depends upon your data points, means how the impactful. See, I would like to ask you one question. See, many of the discussion point will come. You guys are thinking about now the theory points, theoretical work. See, theoretical work means the questions are important. The way you asked about which number we have to take or how to predict or state of random. These are the points are not impactful on them. It's not like that and 10 question means you can pass the random state is in 10 if you're passing random state is in 100. See, if you pass a 10 and you slice down the data set, see what I'm saying? If you pass down a 10 random state and you have sliced down the data set and you are getting 80, 20, 80, 20, and model is saying that transaction isn't true. Can you tell me the possibilities to answer remain same while random state if your changes into the 100? Your random state is in 10 and that time your model is saying that what your transaction is true. What is the possibilities while changing the random state is equals to 100? Answer remains same. Is it possible? Is it possible what I'm saying? Question Rohan. Please explain test and train. That's going on. Yes, Rahul, I will. So for different classification, we use about same random state. You can. That's a good question. You can use, yes. Simple multi logistic can, and you can see it depends upon us that how much random means random state you are passing. If you are passing 5 to all the algorithms, that's good. But just think about it. You should work on the same data set with the different algorithms with the same random state. That matter. And the way I asked one question, your random state impact on your output. Are you getting my point? Random state impact on output. That is a very rare case. Your output should be remain same. But if you change the random state, your data points are changes. Testing site and training size. Are you getting a point?
Hello, sir. Rohan is here. Hello.
Rohan.
Sir, can you explain test word, test and train word?
Um, Test
I'm
and
not
train.
getting that word. Is it function or why we
Train
take
test
trace?
split function. That
Yes.
actually the train test split is in class, and that gives you a splitting concept. And now when I use the train test split into the bracket, that is become as a method. But Ron, you got the point. Great. Rahul, so which one to believe than 80-20, 70-30, 90-10? That's the good question now. Actually, many people says that why to train 70-80? Why not I train only 50 and then I will ask 50% of question? See, it depends upon you. What will happen? You can train even 100% of data. What I said, you can train 100% of data, but how can you believe on your data set that he is telling you true? Because you have to take some data to your side so that you can ask to the model. Wait. See, one thing here I'm just mentioning here. Suppose the way I have studied, 10 chapters are there and the student is there. Okay. Yes, Rahul, I'm just giving you this question's answer. Wait, I will tell you. And definitely, the thing that I'm explaining you now, that will be useful to you in future as well. So just concentrate on the screen, guys. Okay, 10 chapters are there. I'm just giving you question chapters. Okay, one subject is there and 10 chapters are there, and 10 chapters there we have the student, and your teacher is saying that I will give you 8 chapters questions before your teacher is giving you 8 chapters questions and answers. Now tell me, question means your training, question means your X data, answer means your Y data, means independent variable and dependent variable, already teaching to your model, already telling to your student, who is telling? Teacher. Now tell me, if you want to check accuracy, what do? You will take a 2 chapters data that you not teach to the model, to the student, that you haven't teached. Once you ask this 2 chapters question, and 2 chapters has an questions and answers. Questions and answers means your X data and Y data, means your independent variable and dependent variable already has. Then then you will get to know the knowledge of student. See what I'm saying? Your 10 chapters data, 10 chapters question, your 8 chapters already asked, teach, you already given the answers and questions to them. But when you go for exam, that time you are asking 100 marks question, means 10 chapters question. Definitely, you will get to know the particular knowledge about your student is giving you good or bad knowledge, means good answers or bad answers, because already he knows. Then how can you check, right? You got the point here? Sir, theory is an important, and even notes. I will tell you, yesterday I told you that after completion of this one, no, in Sunday evening, I will upload that tomorrow. I think I will go for the Monday. Sunday continue sessions will be there. But yes, Ron, I will share some of the notes. Questions now. Questions now. What will happen? Always, you guys will ask about. Will ask one question about how much how much test size and how much train size we should have to set. If you train 100% of data to the model, see, if you train 100% of the data to the model, how can you check your accuracy? how can you check your accuracy? If you have 100 of data points, see what I'm saying? Hundreds of data points in data set. What you do, you will teach your whole data. Means your whole data means 100 data points. Okay, whole data. Then tell me, if you want to check your model is correct or not, then which question you will ask? You have to create your own artificial, means your own artificial questions. You have to create your own questions that you don't know the answer as well. Only assumptions. You will ask, if suppose that 40 years of experience, then what will be the answer? If you are having 35 years of experience, then what will be the salary? That is the wrong thing, no? If you know this year of experience and year of if you know the year of experience and salary, then you will believe on that actual data. That's why you are going to ask. So no need to ask your 100% data point, means 100% whole data to the model. That's the wrong thing. Second, if you teach 90% of data to the model and 10%, means if you take a side of 10%, teach 90%, then also it's good. Even 80% is good. But if you think about 60-40, see what I'm saying? If you think about 60-40, it depends upon your data points as well. If suppose you have a 1000 data points and you are teaching your 600 data points to the model and you are asking 400 questions to the model, that is this, tell me this is correct or not, that's the wrong thing as well. So always keep remember that how much data you are teaching to your model, that's the main point. If you are teaching highest numbers of count to the model, then definitely your model should be a stronger, more than stronger. But you have to take some data to side that you can ask to the model. Is it correct, guys? What I'm teaching to you, what I'm telling to you? Great. See, the till thank you so much. Thank you, everyone. Thank you. See, the way I said that training, testing, splitting means these 2 points and all, actually still I never entered into the data, means prediction point. Why? You know what? Actually, once I explain this steps, no, when I go for the next algorithm, you will not ask any question about the first stage, second stage, third stage, and fourth stage, because you know that that is why I have assigned the random state is equals to 200. If I say their test size is equals to 0.3%, then definitely you know that test size 3% means 30% is in testing size, 70% is in training size. And if I print, suppose this one, check out. What is the total size of your data set actually? Wait, I will show you. Shape 30. See, actually, this is a small data set, so do not worry about it. 30. If I pass their test size equals to 0.2%, what it is? Ubari, thank you so much. What is the 20% of your third is 30 data count? 6, no? Is it correct? 6, and remaining are 24. So why not I check for that? The way I have passed the test size equals to 0.2%, and why not we check about the size of X test, X train, Y train, Y test. So let's go for this checking. I'll take this one. All these results are here. Copy because I'm just thinking about dot shape, dot shape, dot vector shape. This is easy work I'm doing here. See, this is my X train dot shape, that is in 24. This is X test 6, Y train 24, and Y test 6. What is your test size? 0.2% means 20%. And you have divided into 80-20. If I say here, see, if I say here 3, check out, I passed here 0.3% and you are getting here 21 to the Y train and X test, X train and Y train, and remaining X test and Y test they are getting a 9. If I say here 4, 0.4, 80, 12, how much? 18. Obviously, no, 6 there. So 3 into 6, that is an 18. 0.4 is an 40%. 0.2, 0.4, 0.1. You can pass the 0.1 as well. So it will be easy to view that we can pass it down easily. We can directly pass a 4. Why not? You can try once. 4. See, trial and error is the most important point. What happened? Same. It's the same. Go on. What happened now? It's not working in the form of percentage. It's working in the form of count. If I say directly, what test size equals to 15, then what? He is taking exactly 15 data points to the testing purpose. If you are not passing into the 0.2, 0.3%, then definitely, I think definitely this is, are you getting that point? If I saying 0.2%, then 20% data is slicing. If I pass 15, 20 directly without precision and means without percentage point, then he will take that much points. That much points. Point represent percentage. Exactly, Rahul. That's why we are getting this one. And you know what? Actually, I know some of the means questions still we haven't discussed about it. Still, we have worked on the step 4 because this is the step 4 is important. Not important your step 5. Step 5 is in your algorithm that we are going to work on tomorrow. Step 5 is an algorithm. But till the step 4, your data should be ready. Why? Because this is the data you are teaching to your algorithm. Now you will ask, if suppose client will gives you me data any kind of that, and I will slice down into the X and Y, and I will put into the I will make a slicing training and testing set, and that's it. That's the wrong thing. That's the wrong thing. Are you getting my point actually? what I'm telling to you. Abhay, let us continue for another half an hour or so. Class is going well today, so well. Actually, what happens, uh, what we are going to do here? Definitely, actually, I will not enter into the step 5 now. Why, Rohan? Actually, what happened? Algorithmic concepts are different to understand, and this point is different to understand till step 4. I know that's the definitely you will get to know, but this is the difference between that. Okay, if I enter now into the algorithm, there we are having near about huge amount of questionnaires you will get. You will forget all the 4 steps when I enter into the algorithm concept. So till today we'll ended up here, but definitely when we'll come tomorrow, no, you will just go through the whole process of step 1 to step 4, and see, step 4 tells you your data is correct. That's why you are teaching to your model. Are you getting my point? What I'm teaching, trying to tell you. Step 4 is telling you that your data is in strong, data is a good. That's why you are teaching to your model. So what's the major point here? You have to have believe in your data set that whatever you are giving to the model, my data is enough to predict anything. If you are not believing in your data points and data set, then it's this you need not to go for this machine learning. You have to learn first data analysis. Load the data set and solve the problem errors, solve the null value problem, solve the string data problem, and solve everything. Then comes to the where, then come to the where machine learning. I think you got the point, guys. This is your today's session. I think you got many problem solving solutions, right? Thank you so much for thank you so much actually. Right. Wait, I will give you a little bit summary, and I'm happy that you have a lot of strong patience, guys. Actually, means you are listening to your colleagues as well. Means whenever someone is asking to you asking some question to me, that time you just listening that questions and solving that as well. Means understanding that one. Test and train are predefined. Yes, yes. That is in class, so that is predefined. So let's go for a little bit summary here. The first step that we have seen, that is step 1, that is loading the importing the libraries. Second one is loading the data set here, and third thing that we have seen here, data slicing, that x and y purpose you have to understand with means you have to slice down your independent data and dependent data. Into interview, no, definitely they will ask you what is the machine learning life cycle, or how do you implement your machine learning algorithm. Then you have to tell them these are the steps that I have done, that's why I got the prediction. Yes, it is. Am I correct what I'm telling to you? Data slicing, and then we have entered into the training set and testing set. Okay, and if you explain your stages, no, that's definitely you will get it very easily. If you stages are important. If you're not having, if you don't know, if you're directly explaining your model, if you are directly explaining your algorithm, no. If suppose someone will say you what is the logistic regression, what is the simple linear regression, then definitely you can go for the particular answer. But if someone is asking to you, tell me this credit card fraud detection, salary prediction, house price prediction, which algorithm you have used, then first you should tell them about problem statement. What you are going to tell means you are going to predict a house price, then go for the step by step result. Sir, first I have covered imported libraries, then data set, then slicing of independent variable, dependent variable, then I enter into where training set and testing set. Then definitely your interview will ask you, do you have completed your data pre-processing, means data analytical things? Then you have to tell them, sir, already I have worked on the data cleaning and data pre-processing, then I entered into prediction. That's why I have value on the data set. Okay guys, I think that's the all things guys today's session, and hope you enjoyed a lot, and thanks for joining this session. I appreciate it. Thank you so much. Thanks for questioning. See you on tomorrow's session. Thank you so much. Take care, you all. Bye bye.